Okay, let me get this pulled up here. There we go. Okay. Okay, so going over trig here, guys. On the first slide here, this is what we had on our formula sheet. You are not going to have this for the final, so you want to make sure you remember how to think through it in your mind about what we're doing. There's 3 things we worked with, really: Pythagorean theorem, regular trig, inverse trig. And you have to be able to look at a problem and know which one you're doing. Let's go ahead and look at the first slide here. Pythagorean theorem, to remind ourselves, Pythagorean theorem is a squared plus b squared equals c squared. We can only use this when we know 2 sides of a triangle and we're trying to find the third. And again, you see that here. We know 2 sides, we're trying to find the third, use Pythagorean theorem. And remember, the only rule is that C is either the biggest side. If I know all 3, then we know that C has to be the biggest side, or visually it's across from the right angle. So here's my right angle. This one has to go in place of C. That's the only rule. So this changes, depending on what we have, it changes on how we solve it. So let's go ahead and look at number 1. Take a second if you guys can and label your picture and then put X by what you're trying to find. So we got CR is 10, we got RT is 10 radical 3, and then it says find CT, and so that's our X. So again, because we know 2 sides, we're trying to find the third, we know we're going to do Pythagorean theorem. There is only one rule, though: the hypotenuse has to go in for C. So whatever is across from the right angle, that's what's going in for C. So take a second and see if you know how to plug in. And more importantly, where is that X going to go? Okay, my X is across from the right angle. So in this case, I am going to plug X in for C. I have 10 squared plus, remember how we deal with radicals? You need to put it all in parentheses. The whole thing needs to go in parentheses. 10 radical 3, close the parenthesis, and the square on the outside. So how we attack this, we want to get X by itself. So what I do is I'm going to figure out what all of this is here. I'm going to go to my calculator, take a second to do so yourself, and plug all that in. Okay, so all of this together, you should get 400 equals, and I still have X squared on this side. So remember, X is not by itself yet. You still have one more step. What should you do here to get X by itself? I need to undo the square by doing square root. So we're going to take the square root of 400, and we got, oh, exactly 20. Okay, so this was just, again, plugging in, getting X by itself. Whatever we have to do, we do. Go ahead and look at number 2. I want you to try number 2 all the way through. Being careful, it's going to be just a little bit different. So see if you remember how to do it. Okay, CR is 12. CT is 15. Find RT, that means RT is X. And so I'm going to A squared plus B squared equals C squared. I have to identify C. I always do that first because C is special. In this case, careful, check your answer. You should have plugged in 15 for C because 15 is across from the right angle to our hypotenuse. So that means X and 12 can get plugged in over here. Doesn't matter which goes first. You could have put the 12 first. So this guy is a little different. Again, how we know what we need to be doing and solving is we have to get X by itself. So everything has to get moved to the other side. Over here, X was mostly by itself, and so we didn't have to do a lot of moving around. But here we are going to have to. So I'm going to drop the X squared down. I need to know what 12 squared is and what 15 squared is. If you haven't done so, take a second, go to the calculator. What are those two? 12 squared is 144. 15 squared, I should have checked. Is that 225? Yes, 15 squared is 225. So again, I'm not thinking about, well, okay, this is a special situation. This is just solving an equation. The next step you should do to get X by itself is you need to subtract the 144. I'm just moving everything away from X like we always do when we are solving an equation. Okay, and I get 81. Now, X squared drops down because I haven't done anything to that yet. My last step is just to take the square root. I got X equals 9. So remember, guys, be careful. You're only going to have one problem like this on your final. It could be one or the other. It really is the same thing. You just end up having to do different math depending on where your X is at. Okay, next thing is Pythagorean theorem converse. So we use this again. It's still Pythagorean theorem, so it's still a squared plus b squared equals c squared. But remember, the way we do this is we set it up like a table. We put c squared on the left, and we're going to compare it to a squared plus b squared. And the reason why we do that is when I look at it like this, if c squared equals a squared plus b squared, we know that's a right triangle because Pythagorean theorem, where it's equal, only works for a right triangle. But if they're not equal, specifically if c squared is less than a squared plus b squared, we know it's acute. So we think less than, we think acute. That's why we write it this way. So if c squared is greater than a squared plus b squared, then we know it's going to be an obtuse triangle. Again, we think greater than, obtuse. So that's why you write it this way. If you write it as a squared plus b squared and then c squared on the other side, you can't quite think this way. So all we have to do is we're verifying. I've got 3 numbers. One of them can be c. Which one of these, 16, 20, and 10, which of these is going in for the c position? 20, because it is the biggest side. So I'm going to go 20 squared. And then a and b again are just the other 2. I got 16 squared and I got 10 squared. So again, because we're verifying, we're not solving, all we do is we see what both of these sides equal. So go to your calculator, plug those both in. So 20 squared is 400. I'm going to go ahead and do this all together. I have 16 squared plus 10 squared. This is 356. So now we come to our conclusion. We think, is the left equal to the right? Is the left smaller than? Is left bigger than? What do we think? Would this be a right, acute, or obtuse triangle? Well, c squared is greater than, the left side is greater than, and so we think obtuse. We read from left to right, and so we say, is the left greater than the right? It is obtuse. Okay, keeping it going here. Next slide, we have trig functions. So up at the top here, I have this line to spell out our best friend SOHCAHTOA. Take a second and see if you remember how to spell SOHCAHTOA. This is S-O-H-C-A-H. That's SOHCAHTOA. Okay, we use this again to help us figure out which trig function we're going to use. So these are our steps. Again, we got to label our sides. We've got the opposite, the adjacent, the hypotenuse. We're going to use those labels to figure out which trig function to use. We set up, we cross multiply, we solve. A little bit entailed, yeah. So we got 2 examples we're going to do here because it takes us a while. Take a second though. It says AB is 10, A is 35. Find BC, that's your X. Go ahead and label the picture. Okay, AB is 10, angle A is 35 degrees, and BC is X. And I'm going to go ahead and leave AC blank. So, again, we have our opposite, we have our adjacent, we have our hypotenuse, but I only need 2 labels. Don't label the blank side. So let's refresh real quick. If you know what you're doing, go ahead and do it. But my hypotenuse is special, right? My hypotenuse is always across from the right angle, and that is my empty side. So I'm not going to label that guy, but that is the hypotenuse. Here's my angle. Across from the angle I'm given, that's my opposite. Opposite to my angle that I'm given, right? All the way through the triangle. That leaves 10 to be the adjacent. This was the hypotenuse. This is the opposite. Adjacent is the last one. So looking at SOHCAHTOA, we have the opposite, we have the adjacent. Which trig function are we going to use? That is going to be tangent in this case. This is the TOA. Or that's what the T stand for, is tangent. So how this is set up, the trig function is always married to the angle. Again, on that first slide, there is the general setup for regular trig. Trig function, angle equals fraction. So my angle is the 35 equals, I need my fraction. Take a second, we have TOA, OA. What's going to go on top? It's going to go on bottom. Well, if this is O over A, my opposite's going to go on top. My adjacent's going to go on bottom. Okay, so here's our general setup. Now remember, when we're dealing with this regular trig here, the way we solve is we need to get x by itself. We think about it like this guy is a fraction. If I make this guy a fraction, I can cross multiply. And then if I have to do more stuff, then I can go from there. but I have 1 times x is x. I have 10 times tangent 35 is, remember, 10 tangent 35. This goes into the calculator. And I can go straight to the calculator because x is by itself. Whenever I do something and I end up with x all by itself, that all can go into the calculator. So let's go ahead and do that. Make sure we're in the right function here. Yep. Okay. 10 tangent 35. Okay, so we should get that x equals 7.0. This is going to round to, so there we go. So try it again. On the next one, I want you to do the whole thing. Again, being careful, though, that when you cross multiply, if x is not by itself, again, we did 1 times x. X is by itself. You need to do something else. So go ahead and try this next question. Okay, BC is 15. C is 20. And don't forget your x. You guys get mixed up. If you didn't put x, you probably didn't know what to do. AC is x. Okay, so I label my sides. My right angle is right here. Always across from the right angle is the hypotenuse. So in this case, x is the hypotenuse. Here's my angle I'm given. The blank side would be opposite, but I don't have it, so I'm going to leave it. That leaves 15 to be the adjacent. So check. Adjacent, hypotenuse, looking back up to SOHCAHTOA. You should have chosen to use cosine. That's A over H. So I've got cosine. Married to my angle, so my angle is going to be the 20. And my fraction is specifically whatever my adjacent is over whatever my hypotenuse is. It's not a choice. My adjacent is 15. My hypotenuse is x. So check your setup and fix it if you need to. X does not always go on top. In this case, x is the hypotenuse, and the hypotenuse goes on bottom. Simple as that. But we still are going to cross multiply, and there's a problem when we do this. When I cross multiply, I'm going to have 15 times 1, which is 15, and I'm going to have x times cosine 20. So is x by itself when I cross multiply? Nope, x still has the cosine 20 with it. So remember, this means x times cosine 20. To get rid of that times cosine 20, I should do the opposite and I should divide. So now when I do this division, again, what that means is this cancels out. That's the whole point of undoing it, is it's all gone, which means x is now by itself, and that's what we want. Meaning I can go to the calculator with this guy, and I've got x. So go ahead and do that. Cosine 20. Okay, so you should have gotten 15.96. Remember how this works, guys? We're going to round to one place, but 96 is going to round up to 100. And so that's actually going to cause this to go up to 16. Okay, you might need some more help with that. Let me know when you're doing the questions on the quiz if you want me to help you, if you didn't check, because we took this very slow when we taught it the first time. We have one more slide we're going to do. It's inverse trig, and thankfully inverse trig is a lot easier. We use inverse trig when you are exclusively finding an angle. If they say blah, 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 find angle x, you know immediately, oh, inverse trig. We're still going to label our sides, pick our trig function using SOHCAHTOA. I'm going to copy it over again just so I have it. But there's no cross multiplying that has to happen. You actually just go straight to the calculator. So let's go ahead and we're just going to do one example here because it is pretty simple. Take a second. You got 3 things you need to label. Go ahead and do so. Okay, xy is 4, xz is 7, and I'm finding an angle. So I'm going to call that x. Just so happens the angle is x as well. That means you have inverse trig. Take a second, label your 4 and your 7. What's your opposite? What's your adjacent? What's your hypotenuse? One of those labels is for the blank side. Leave that label off. Okay, well, my opposite is the blank side. So you shouldn't have labeled opposite. Across from the 90, this is my hypotenuse. That leaves 4 to be the adjacent. So looking back up here again, yes, this is once again AH. You should have chosen cosine. Now again, how inverse trig works, we can skip right to this. Typically, we see this, right? Typically, we would see cosine of my angle, which is x, equals my fraction, right? So my fraction should be, take a second to write your fraction. Fraction should be the adjacent over the hypotenuse, should be 4/7. This is typically how we see regular trig. But remember, the reason we call it inverse is these guys switch places. That's the definition of an inverse. So I can make these guys switch places. 4/7 equals x. Hey, x is by itself. We know that's good. How we switch places, though, is we have to use an inverse trig function. You need that little -1. So let me know if you forgot how to plug this in the calculator. You can just raise your hand and I'll come around and help you. But x is by itself. This just goes in the calculator and you've got your answer. Cosine 4 divided by 7. Okay, so you should have gotten to the nearest tenth, 55.15, so that should round to 2. Okay, so there is one more problem on the quiz that you, again, just raise your hand if you need help with it. It's the word problems. It's doing one of these things. You just have to be able to draw the picture. And so if you need help with drawing the picture, you can let me know. And at any point at all, raise your hand. I'll come around and help.